Hello. Today we are going to be dividing polynomials by linear expressions such as x plus 2, where you have a constant and a term to the first power. First going to be in English y después va a ser en español. En la descripción pongo donde comienza esa parte. Okay. Keep in mind that your answer is going to be in the form p of x, which represents the quotient, plus an integer, and I called it r. You can, other people call it different name, but I called it r because that integer represents your remainder over d of x, and d of x is going to be your divisor, what it is that you are dividing. So for this particular equation, if I have a remainder that is not 0, then I'm going to have my d of x is going to be my divisor of x plus 2 here at the bottom. Okay? Now, I will share the videos from Khan Academy, which show you how to do with long division. In class, I've done it with synthetic division. So I'm going to now do this with synthetic division. Okay? Now, before I move on, I'm going to go ahead and put information here that's missing. For example, the term x squared, its coefficient of 1 is missing. When you don't see a coefficient, it's 1. And it's positive 1 because I'm adding x squared. And then here I'm going to go ahead and put the invisible exponent of 1. And notice that there are all the terms, all the exponents have a term here. We have a term for the exponent to the third power, term exponent to the second power, term exponent to the first power, and after that we have our constant 12. So first I'm going to, step 1, I'm going to take the divisor. So the divisor is this guy right here, and I'm going to set it equal to 0, and I'm going to solve for x. So I want to get x by itself. So plus 2 means I'm going to subtract 2 from both sides. So x is equivalent to 0 minus 2 is negative 2. Step 2. S2 is for step 2. I'm going to bring down all of the coefficients and then the constant in standard form. It starts with the term with the highest exponent and works its way down to the lowest exponent at the very end is the exponent of 0, or in other words, our constant. So the first coefficient is 3. The second coefficient is 1. Notice it's positive 1. The third coefficient is negative 4. The sign always follows the number that comes after. And then I have the constant of positive 12, so because plus. And here I have a little box, and in that box I'm going to put the number that I got for x in step 1, which is negative 2. Then I'm going to draw a line, and I'm going to leave a room for a line of numbers. So I want to make sure I have room for a line of numbers here, and you'll see why. So the first thing I'm going to do, the first coefficient, you bring it down as is, nothing happens, just bring it down, past the line. So then you're going to take that number that you brought down past the line, and you're going to multiply it to the number in the box. 3 times negative 2 is negative 6, and that's what I put here underneath the next number. Then I'm going to combine like terms. I'm going to add the numbers and bring them down below the line. So 1 plus negative 6 gives me negative 5. And I'm going to repeat the process again. The number past the line, multiply times the number in the square, that gives me 10. I put that number here in the next open space. And then I'm going to combine combine these two numbers. I'm going to add negative 4 plus 10 and bring it down below the line. Negative 4 plus 10 is a positive 6. And I'm going to repeat the process. 6 times the number in the box, negative 2, is negative 12. Right there. And then I combine again 12 plus negative 12 actually gives me a 0. And that last number that I brought down, I'm going to put in the box. And this number always represents your remainder. This says remainder, by the way. That's my R. Now, because I have a remainder of 0, my answer is just going to be in the form of p of x. And we'll see, I'll show you why. we're not done yet. We've just come up with the new coefficients for the quotient here. So everything here not in the box. So this becomes the coefficient to x to the second power. Notice that here the dividend has the highest exponent of 3. So its degree is 3. So 1 less is going to be 2. So it's always 1 less to the highest exponent, and then you work your way down. Now why 1 less? Because we're dividing. Or we're dividing, we're subtracting. Division is repetitive subtraction. So now that I have this, I'm going to bring down the -5, and the next exponent after 2 down, so I subtract 1, is going to be to the first power, but I'm not going to write to the first power because it's an invisible 1, right? And then, because I used the last exponent, which is the exponent of 1, to the first power, that means the next number that comes down is not a coefficient, it's the constant. That's a +6, so I add 6. And that's my answer. Why does it stop there? Because there's no reason for me to continue. I could show you that technically it's my quotient plus the remainder over the divisor. The remainder in this case is 0, divided by the original divisor is x plus 2. But we know that if you divide 0 by any number, it becomes 0. 0 divided by 10, 0 divided by -100, it's 0. So, and then 6 plus, so this becomes 0, and then 6 plus 0 is just 6. Hence why your answer is just what we had original. Because once you further simplify, you get this. Now, because my remainder is 0, that means that x plus 2 divides evenly into the polynomial here on the numerator, the dividend, which means that x plus 2 is indeed a factor of the polynomial expression, 3x squared plus 1x squared minus 4x plus 12. Let's do a few more examples. You're always free, since you have control of your mouse, to pause and go back, okay? We're going to do another example. We're going to do a few more, and they're a little bit different. So I urge you to watch the other examples that I am about to go over. Okay? So we have here, let me write it down, 3x to the 4th power minus 3x to the 3rd power minus 9x to the 2nd power. Oops, a lot of minuses, plus 5x and minus 2. And we are going to divide that expression by x minus 2 in this case, not x plus 2. It could be any number, but let's just do it that way. Okay? So first, again, step 1, I'm going to take the divisor, so what you're dividing by, instead of equal to 0, because I subtract inverse operation, I'm going to use the addition property of equality, add 2 to both sides. X equals 0 plus 2 is 2. Let's take a look. We have a term to the x to the 4th, term to the x to the 3rd, term x to the 2nd, term x to the 1, and my constant. So all the terms are there. So, and I have all the coefficients present. So I'm going to go ahead and bring down, and then notice it's in standard form. From the highest exponent, works its way down to the lowest exponent until you have a constant. Okay, so that's good. So I'm going to go ahead and bring down all the coefficients. That's going to be a -3, -3, it's going to be a -9, it's going to be a +5, it's going to be a -2, and in the box here, I'm going to put what I solved for in this case is a +2. Now draw my line, and now for a row of numbers. However, the first number just goes straight down past the line. So now I'm going to go ahead and start the process of multiplying the number I brought down times the number in the box. Again, this number came from step 1. 3 times 2 is +6. Then I'm going to combine those two numbers by adding -3 plus 6. That gives me a +3, so that's the number I bring down after I add those two numbers. I repeat the process 3 times 2 is positive 6. And I'm going to add those two numbers. Negative 9 plus 6 gives me a negative 3. That's what I bring down when I combine those numbers by adding. When I have negative 3 times 2 is negative 6. So I put that there. And again, I'm going to combine those numbers by adding. 5 plus negative 6 is negative 1. And then I'm going to multiply again. Negative 2 times 2 is negative 2. Notice they're not opposite numbers. So when I add negative 2 plus negative 2, I get negative 4. So I do actually have a remainder, r, of negative 4 that isn't 0. 0 is a remainder, but in this case, it's not. So let's move on to step 3. I didn't mention step 3, but the last one, but we did it. I just didn't put this here. Step 3, now we have all the coefficients and constant for our answer. So we're going to bring down the first coefficient, and it's going to be to the coefficient to the third power, because again, if you go to the dividend, the polynomial expression that you want to divide, and the degree of the highest exponent is 4, 1 less than that is 3. So now I'm going to work my way down. Then I have to bring the coefficient, which is 3. Positive 3 means I add. And 1 less exponent is going to be 2. 3 minus 1 is 2. So now I'm going to bring the coefficient for 1 less for the exponent of 1. So this is minus negative 3, so I'm going to subtract 3. Okay. So that's going to be x to the 1 less is to the first power. Okay, I've used up the last exponent of 1. That means the next number left here is going to be my constant. Okay. Now notice I do have to continue. I'm not done because the number is not 0. I do have to then do plus remainder, the integer that is represent my remainder, over the divisor, which is the same divisor from the original problem. So I'm going to put add plus. Please don't forget the plus. Okay. The negative 4 goes above, and the x minus 2, the original divisor, goes on the bottom, and I am done. If you forget to do this and you write it like this, for example, it's not correct because then it looks like you're multiplying this fraction to the negative 1, and that's not what we're doing. We're adding the fraction to the quotient. Okay. Now you could decide, well, plus a negative is the same thing as subtracting. You could do that, and that's nothing wrong with that. However, if it's easier for you to just be consistent no matter what, just do plus and whatever that number is, the sign goes with that number there. Okay? Now, I'm going to give you a watch out. If you do synthetic division, you may run into a problem. Not a problem. You may run into having to do an extra step at the end. If you do synthetic division, you do long division will always give you the most simplified form of the answer. Here, in many cases, synthetic division works because if you notice, if you look at just at the quotient, which is the number represented by the expression, the polynomial expression in front of the fraction of the remainder over divisor. Notice here, this is the coefficient of 3, of negative 2. If this number had been any number that has 3 as a factor, then I would actually have to simplify that. So for example, let's assume I got this, where 3, 3, 3, negative 3, negative 6 all have 3 as a common factor. I would have to divide everything by the largest factor they all have in common, the greatest common factor. In this case, it would be 3. To simplify it even further. So 3 divided by 3 is 1, so it goes 1 times x to the cube is just x to the cube. 3 over 3 is 1. Any number divided by itself is equivalent to 1. And 1 times x squared is just x squared. We normally don't put the invisible 1. Negative 3 divided by 3 would be negative 1 or negative x. And negative 6 divided by 3 would be a positive 2. So then this would be the simplified version of the quotient. In this case, synthetic division gave me the most simplified answer because the constant of -1 does not have 3 or -3 as a factor, so I don't have to continue. Not that it's wrong per se if you didn't simplify it, but depending on your teacher, depending what's expected, you may get points off for not having it completely simplified. Now, in this case, in most cases, synthetic division it is. So the last thing you have to just check is, are there any common factors here that I can divide out to simplify in the quotient, so not including the fraction? And if the answer is yes, then you have to find that greatest common factor and divide all the numbers there, the coefficients and the constant, by that number. Let's do another example, okay, where we are missing a term. Okay, it's going to be 2x to the 5th power minus 15x to the 3rd power minus 9x squared plus 11x, oh my goodness, plus 12. And we are going to divide it by, also x plus 2. It could be -5, it could be +3, -1, +10, it could be any number. In this case, it also happens to be x plus 2. So again, first step, I take the divisor, set it equal to 0, and solve. So I'm going to take away 2 from both sides. So the 2 minus 2 becomes 0 plus x, which is just x. 0 minus 2 is -2. Now I'm going to go ahead and bring down the numbers. Notice it is in standard form. It's to the dividends. So this polynomial expression starts with the highest exponent and works its way down to the lowest exponent, all the way down to the constant. However, notice that the term x to the 4th is missing. And you may have noticed from prior videos that when you see something, a term missing like x to the 4th, it's because its coefficient is 0. Because 0 times x to the 4th is 0. And therefore, 0 plus the number, like 12. I can combine a number plus a number. 0 plus 12 is 12, so that's why it's not there. So we have to keep that in mind when we're doing division, synthetic or long division. So let's go ahead and bring down 2 is the first coefficient for the x to the 5th. I'm going to bring down 0 for the coefficient for x to the 4th. -15 is the coefficient for x to the 3rd. -9 is the coefficient for x to the 2nd. +11 is the coefficient for x to the 1st. 12 is the coefficient for x to the 0, or actually it's the constant, excuse me. 12 is the constant, or the coefficient x to the 0. And then that little box comes from step 1. So I'm going to go ahead and bring down the first number, make sure my line, enough room for a row of numbers. I'm going to go ahead and start the procedure. 2 times -2 is -4. 0 plus -4 is -4. -4 times -2 is a +8. 8 plus -15, or -15 plus 8 is what? -7. -7 times -2 is +14. And -9 plus 14 is going to give me the 5. 5 times -2 is -10. 10 plus 11 plus -10 is 1. 1 times -2 is -2. 12 plus -2 is 10. That last number is always my remainder, my R. Notice I'm only going to have that last step because 2, 4, -7, 5, and 1 don't have a factor other than 1 in common. So my answer using synthetic division will be the final answer, the most simplified. So I'm going to get 2. I'm going to bring it. It's going to be x to the 5th. So it's going to be x to the 4th, 1 less. This is going to be the coefficient for x to the 3rd. That's going to be the coefficient for x to the 2nd. That's going to be the coefficient for x to the 1st. And then I use the last exponent. So therefore, it's going to be the last number is going to be that. So now I have my p of x, or you call it my dividend, plus remainder is not 0. So I have to do plus remainder over. Remainder is positive 10 over my divisor, my original divisor, x plus 2. And I'm done. Now, notice you have to bring down, let's assume, guys, because I don't want to do too many, but let's assume instead of -4, assume you got 0. You still have to bring you would still have to bring the 0 down. It would just be plus 0. And that just means that your final answer wouldn't have the term x to the 3rd because 0 times any number becomes 0, and then 0 plus 1 becomes just 1. So you would do this. But obviously, in this particular example, you didn't get a coefficient of 0. So it's really important that you bring down every single number and you work your way down for every single exponent until you get to the number. And then, of course, if you have a remainder that is not 0, you have to do plus remainder over your original x plus 2. Hi. So I actually want to show you how you could input your answer for dividing a polynomial by a linear expression in Khan Academy, so you know how to use the buttons. So I'm sharing with you my screen right now. Let's say I went ahead and on paper, I divided that polynomial expression by the divisor x plus 2, and I got an answer, and I want to put my answer. Let's say my quotient is 3x squared minus 5x plus 6. So I would type in 3x. And to do the second power, if you notice where my cursor is, you see a button that says a to the b. If you click that button, it's going to allow you to put the exponent to the second power. Now notice I'm still in the exponent. So I'm going to click my right arrow. So I can now go back to the main floor, so to speak, and I'm going to put the minus 5x. And I'm just going to type minus 5x in my keyboard. And then I have plus 6. Now, this, let's say I got a remainder that isn't 0. I do have to do plus my remainder, k, or whatever number you give it. Khan gives it a k. I give it an r. My remainder that you got when you did the division divided by your original divisor, which you could see in this problem for Khan, it's being divided by x plus 2. So I'm going to go ahead and do the plus because I'm going to add that fraction. And if you notice, there's another button here in Khan Academy that looks like a fraction x over y. So if you press it, it's going to give you the option now to input a fraction. And let's say that I got -10. And then below, it's going to be, of course, the same divisor. So now I have an answer. And then you would click check to be done. That's it. Vamos a hacerlo ahora en español. Vamos a dividir usando, vamos a hacer aquí. Voy a explicar aquí lo que yo hice mejor. De esa manera va a ser un poquito más fácil. Aquí tengo la expresión, es un polinomio dividido por x más 2, es una expresión lineal. La respuesta final tiene que tener el quotient más el remainder sobre el divisor. Si el remainder es 0, solamente vas a tener solamente el p de x. Por la luz del día. Okay. El primer paso, tomé el divisor, lo puse igual a 0 y resolví por la x. Entonces, como es más 2, como es más 2, perdón, Voy a restar 2 a los dos lados para que baje solamente x igual a negativo 2. Porque 0 menos 2 me dio negativo 2. El segundo paso, voy a bajar todos los coeficientes. Si se dan cuenta, la expresión polinomio arriba está en forma estándar. Porque comienza con el término con valor del exponente más alto y cada término baja el valor del exponente hasta que llegue al constante. Otra cosa que se dan cuenta, que el término x al cuarto poder no está ahí. Y todos los términos, comenzando con más alto, tiene que estar ahí. X al quinto y después va a x al tercer. Entonces, ¿qué significa eso? Si se recuerdan viendo videos previos, que cuando no ven un término es porque el coeficiente es 0. Entonces, sí está ahí, porque 0 por cualquier número me da 0. Y 0 más el número aquí 12 es 12. Entonces, por eso no ven el término con x al cuadrado, porque tiene un coeficiente de 0. Por eso cuando bajo los números en orden, en la orden correcta, voy a poner un 0 cuando llega su tiempo. Por ejemplo, primero si bajé 2, el coeficiente de x al quinto poder. 0 es el coeficiente para el término al 4 poder. Negativo 15, el coeficiente para el término al tercer poder. Negativo 9, el coeficiente para el término al segundo poder. 11, el coeficiente para el término al primer poder. Y lo que queda aquí es 12. Arriba aquí pongo la cajita, pongo el valor que me dio en paso 1. Como me dio negativo 2, pongo en la cajita negativo 2. Después escribí una línea aquí, con espacio aquí. Bajo el primer número 2 aquí. Y voy a multiplicar 2 por negativo 2, me dio negativo 4. Si sumo 0 más negativo 4, me da negativo 4. Repito el proceso, negativo 4 por la cajita negativo 2 me dio positivo 8. Si sumo negativo 5 más 8 me dio negativo 7. Repito el proceso, negativo 7 por negativo 2 me dio positivo 14. Si sumo negativo 9 más 14 me dio positivo 5. Repito el proceso, 5 por negativo 2 me dio negativo 10. Si sumo 11 más negativo 10 me dio 1 positivo. Repito el proceso, negativo 1 por negativo 2 me dio negativo 2. Y si sumo negativo 12 más negativo 2 me dio 10 positivo. Ese número último abajo siempre es el remainder. Y tengo lo que queda, tengo que poner aquí la cajita. Si me da 0, el remainder es 0. Si me da otro número, tengo que ponerle en esta forma. Es el número, el remainder, sobre el divisor original, que aquí es x más 2. No hemos terminado porque ahora tenemos que poner la respuesta final. Primero, este es el primer coeficiente y el valor del exponente siempre es 1 menos del valor mayor de la expresión polinomio que estás dividiendo. X aquí al quinto poder, entonces un valor menor, comienza la respuesta x al cuarto poder. Ahora, bajo los coeficientes y tengo que bajar en orden. Entonces, lo que bajo después, el negativo 4, es el coeficiente al tercer poder, porque bajo 1 es el tercer poder. Bueno, bajo el negativo 7 es el coeficiente para el término al segundo poder. Si bajo el 5 es el coeficiente al término al primer poder. Y lo que bajo al final es el número. Si ya usé el 5 para el término al x al primer poder, lo que viene después es el constante. Y como tengo aquí un remainder que no es 0, tengo que decir más. Arriba va el remainder y abajo va el divisor original que estoy dividiendo. Si por cualquier razón tienen un número aquí que es 0, hay que decir, porque ya tenemos la respuesta. Hay que decir que aquí te dio un 0. Tienes que seguir el mismo método. Este es el coeficiente para x al 4 poder. El 0 sería el coeficiente para x al tercer poder. Pero 0 por x al tercer poder causaría que se convierte en 0 y no está en la respuesta. Porque 0 más 1 es 1. Pero obviamente eso no pasó aquí. Eso no pasó aquí. Entonces lo que bajé en mi respuesta final es esto de aquí. ¿Ok? Ahora vamos a hacer una, porque sé que es largo, y ojalá que trataron de ver en inglés para poder practicar el idioma en inglés. ¿Ok? Ok, vamos a hacerla de aquí. 4x al tercer poder menos 2x al segundo poder más x menos 3 dividido por x menos 1. Es diferente a la que hice en inglés. Si quieren ver también la de allá. Primero voy a poner, antes que continúe, veo que x no tiene coeficiente, sí está ahí, es uno imaginario, perdón, uno invisible. Si ve solamente x es porque su coeficiente es una x, 1 por x es x. Y obviamente aquí tenemos el exponente 1 invisible. Ok, primer paso, tomamos el divisor, lo que estás dividiendo por, y le pones igual a 0. Vamos a resolver por x. De otra manera, vamos a usar la propiedad de adición de igualdad para poder tener x igual a 1. X menos 1 más 1 me da solamente x, 0 más 1 me da 1. El segundo paso, vamos a bajar todos los coeficientes y el constante. Como ven, ya está en la orden estándar. Tiene que estar el divisor, esa expresión polinomio en forma estándar, donde comienza con el término, con el exponente más grande y baja hasta que llega al constante. El primer coeficiente es 4. Coeficiente x al tercer poder, negativo 2. Coeficiente de x al segundo poder, positivo 1. Coeficiente de el término x al primer poder y el constante. No tenía que poner un 0 porque ven que todos los términos, comenzando con el exponente más grande, están ahí. No hay, aquí yo tenía que poner un 0 si, por ejemplo, no veo el término x al segundo poder. Pero como sí está el término x al segundo poder, voy a poner el coeficiente que vemos. Y aquí tengo la cajita y la cajita va a tener el número que nos dio en paso 1. Ahora, voy a hacer la línea que tenga espacio para los números. Primero voy a bajar el primer número, 4. Voy a multiplicar ese número por el número en la cajita, me dio 4. Ahora voy a sumar, negativo 2 más 4 me da positivo 2. Eso es lo que bajo debajo de la línea. Después repito el proceso. Este número multiplica por el número de la cajita, me dio 2. Y voy a sumar 1 más 2, me da 3. Ahora otra vez voy a multiplicar 3 por 1, me da 3. Y voy a sumar, negativo 3 más 3 me da 0. Voy a poner otra cajita. Y ese número siempre va a ser mi remainder, lo que queda. Ahora, tengo todo listo. Voy a poder bajar los coeficientes. Primer coeficiente. Y va a ser, como se dan cuenta, el exponente más grande de la expresión polinomio que está arriba, el dividen, es 3. Y 1 menos 3 es 2. Entonces, comenzamos con el valor, con el término x al segundo poder. Entonces, el número que sigue va a ser para el término x al primer poder, porque tenemos que bajar 1 menos 1 menos. Como es 2 positivos más 2. Entonces, como usé ese número, usé para el término al primer poder, el último exponente que vemos, voy a bajar el constante. Y aquí está mi respuesta. ¿Por qué no continúo como hicimos la primera, como le expliqué la primera vez? Porque si lo hago así, está poniendo más cosas que no debo de poner, porque me va a llegar a la misma respuesta que tengo aquí. Porque aquí, en esta fracción va el remainder, lo que queda, 0, sobre el divisor original. Pero cuando divides 0 por cualquier número, me da 0. 0 dividido por 100, 0 dividido por negativo 2, cualquier número me da 0. Entonces, ese se convierte en 0. Y 3 más 0 es 3. Entonces, esta es mi respuesta final. Ahora le quiero enseñar a ustedes cómo poner su respuesta en Khan Academy si están usando eso de ahí. ¿Ok? Hay que decir que si ven este problema aquí, este polinomio dividido por el divisor x más 2, y hay que decir que me dio esta respuesta. ¿Cómo pueden poner esa respuesta ahí? Ok, le voy a enseñar. Primero voy a poner, si quiero poner el término 3x al cuadrado, 3x, y para subir, para poner el exponente, si ven dónde está mi flechita, aquí hay un botón que dice A al poder B. Hagan clic a ese botón y ahora voy a sube la línea para poner el exponente de 2. Se dan cuenta que la línea aquí todavía está en el exponente. Entonces, para bajar al plano normal, van a poner en su tecla la flechita derecha una vez y bajó. Ahora yo puedo poner menos 5x, estoy usando mi tecla normal, más 6. Y hay que decir que le dio un remainder que no es 0. Entonces la K o la R, cualquier no es 0. Tienen que poner la fracción aquí, su remainder, dividido por el divisor. Aquí divisor x más 2. Entonces, ¿cómo voy a hacer esto? Primero voy a poner mi símbolo de más en su tecla. O pueden, y si no encuentran el símbolo de más en su tecla, está aquí. Y voy a poner, si ven aquí este botón, es una fracción x sobre y, es una fracción. Y ahora, cuando pongo eso, voy a poder poner mi fracción como la he escrito yo. Aquí me dio un remainder negativo 10. Ahora puedo usar mis flechitas en mi tecla, o puedo usar también el cursor aquí y pongo aquí x más 2. Y cuando yo termino, voy a poder poner chequear. Eso es todo.